Hi guys, so today we are going to solve some questions on the concept of HCF and LCM. First question says find the HCF of 279, 465 and 775. Now we have to find HCF of these three numbers. So let's use division method. First, I'll use first two numbers, that is I'll do 465 divided by 279 and then I'll follow the steps. So 279 ones are, the remainder is 186. Now 279 would be carried forward, it would become divisor, it would become dividend, 279 will become dividend, and the remainder will become divisor. 186 ones are, the remainder is 93. I'll again carry forward 186, as in it will become the dividend. 93 twos are 186, the remainder is 0. Hence, I can say that the HCF of 279 and 465 is 93. But over here, there are three numbers that we have. So 93 is not the final answer. So when we have three numbers, we will compare the HCF with the number which is left. And again follow the same steps. 93 8s are 744, remainder is 31, 93 carried forward. 31 3s are 93, remainder is 0. And now I can say that 31 is the final HCF. It's the HCF of 279, 465 and 775. Moving to the next question. Find HCF and LCM of 24 by 50, 4 by 5 and 32 by 30. Now before applying the formulas that we have, first we'll cancel out the values if we can. So 24 and 50 can be cancelled out by 2. Similarly, 32 and 30 can be cancelled out by 2. And these are the values that we will work with now. Now we will just apply the formula. So HCF is equal to HCF of N upon LCM of D. N is numerator, D is denominator. So we'll find HCF of 12, 4 and 16, that is 4, and LCM of 25, 5 and 15, that is 75. Hence HCF is 4 upon 75. Now, for LCM, we will make use of LCM formula, that is LCM of numerators upon HCF of denominators. So LCM of 12, 4 and 16 is 48 and HCF of 25, 5 and 15 is 5. Hence LCM of these three fractions is 48 upon 5. So option 1 is the final answer. Moving to the next question. Product of two numbers is 1985 and their HCF is 5. Find their LCM. Now there's a formula to solve such type of questions. So product of two numbers is equal to HCF square into product of uncommon factors. Now substitute the values in the formula. 5 square is 25 and 1985 divided by 25 we'll get, because I'll transfer this 25 to the left. And if you observe, 1985 divided by 25 is not possible. If it's not possible, how can we find a value? How can we get an answer? Answer cannot be in decimals, because none of the values are in decimals. If none of the values are in decimals, how can we get the answer in decimals? So option 5, data inconsistent, is the option that I'll mark. Moving to the next question. HCF of two numbers is 7 and their sum is 140. How many pairs of the numbers exist? Now, we know the concept that if we have HCF, we can go to the original numbers. Just by assuming it as A and B. So, the original two numbers would be 7A and 7B. There's just one condition to it, that is, A and B must be co-prime. So, according to this concept, we will get an equation that says 7A plus 7B is equal to 140, and after solving this, we'll get A plus B as 20. Now pick out the pairs that will give you the sum of two numbers as 20. So 19 plus 1, it's 20, 18 plus 2, it's 20. All these are the pairs. But A and B must be co-prime. So we will just pick the pairs which are co-prime. So after eliminating all the non-coprime pairs, we'll be left with 4 pairs: 19, 1, 17, 3, 13, 7, and 11, 9. So we will get 4 such pairs. Hence option 2 is the final answer. Moving to the next question. HCF of two numbers is 7 and their LCM is 140. How many pairs of the numbers exist? Now, we will again make use of the same concept. But over here, we know that the formula of LCM is HCF into uncommon factors. So let us take the uncommon factors as A and B. Also, those uncommon factors has to be co-prime. So 140 into 7 into A into B, we'll get A into B as 20. Now figure out all the pairs of A into B as 20. So these are the pairs that we have. Now we just have to pick out the co-prime pairs. 2 and 10 is not a co-prime pair. Hence, we can only have 2 pairs. So option 3, 2 is the answer. Moving to the next question. A number when divided by 4, 5 or 7 always leaves a remainder of 1. Find the smallest such numbers. Now, there's a formula that we can apply when we come across such type of questions. So first, we'll simply use the formula, that is number is equal to k, which is quotient. Quotient can be assumed as any variable, into LCM of divisors plus common remainder. So LCM of 4, 5 and 7 is 140. So 140 into k plus 1. Now to get the value of n, we just have to put in the value of k. That's it. So as we need the smallest value, I'll put the value of k as 0 first. Smallest number would be 1. And to get the second smallest value, I'll put the value of k as 1. I'll get the second smallest number, that is 141. Option 5, none of these is the answer. Moving to the next question. Find the second smallest number which when divided by 4 leaves a remainder of 2, when divided by 5 leaves a remainder of 3, and when divided by 7 leaves a remainder of 5. Again, there's a formula which we will apply when we come across such type of questions. There's just one condition, that the difference must be same between divisor and the remainder in each case. If the difference between divisor and remainder is same in each case, only in that case we can make use of the formula, which we will see just now. Formula is number is equal to k into LCM of divisors minus divisor minus remainder. So k into 140 minus divisor minus remainder in each case is 2. So n is equal to 140k minus 2. Now substitute the value of k to get the smallest number. Don't make a mistake of substituting 0 over here, because if we substitute 0, we will get a negative number, which is not acceptable. So if you can't take 0, take 1. So 140 into 1 minus 2, that's 138. And 38 is the smallest number. Second smallest will be, I'll simply substitute the value of k as 2. So it is going to give me 278. So option 3, 278 is the answer. Moving to the next question. There are 132 mangoes, 84 bananas and 144 watermelons. If equal number of fruits are distributed to every student in the class, such that each student gets only one type of fruit, then what is the minimum possible strength of the class? Over here, we have 132 mangoes, 84 bananas and 144 watermelons. As we need minimum students, we need to distribute maximum fruits to each student. If we have to distribute maximum fruit to each student, we will simply take HCF of 132, 84 and 144. So HCF is 12. That means I can give 12 fruits to each student. So how many students would get mango? So for that, I'll do 132 divided by 12, that is 11. For bananas, it would be 84 divided by 12, that is 7. For watermelons, it would be 144 divided by 12, that is 12. Take a sum of this, the sum is 1. The sum is 30. So option 5, 30 is the answer. Moving to the next question. When the numbers 5361, 5685 and 6333 are divided by the same 3-digit number, you end up getting the same remainder. Find the 3-digit number. This means we have to find divisor in this question. So let's make the equations. So these are the equations that we have. I have assumed the value of divisor, a 3-digit divisor, as n. P, Q, K are the quotients. As the divisor is common, in each case I have taken n, capital N. Now let's solve the two equations simultaneously. So first I'll solve first two equations. After solving first two equations, I'll get n into q minus p as a 324. After solving the second and the third equation, I'll get n into k minus q as 648. Now, in 324 and 648, there's a 3-digit number common. So let's try to figure out the value of n. So we'll figure out all the common numbers, all the common 3-digit numbers between 324 and 648. So the common factors are 324, 162, 108. And all the common factors are 3-digit numbers. Hence, we cannot find a definite answer. If we cannot find a definite answer, cannot be determined will be the option that you will mark. So option 5 is the answer to this question. Moving to the next question. 3 cans A, B and C contain 65 liters, 50 liters and 160 liters of milk respectively. A bucket is used to remove milk from the cans. Only full buckets of milk can be removed and same bucket is used for all cans. After the bucket was used to remove milk, there were 9 liters, 8 liters and 6 liters in cans A, B and C respectively. How many buckets full of milk were removed in all? Now, the buckets removed are equal in quantity. Liters of milk left. 9 liters from 1, 8 liters from 2 and 6 liters from 3. That means we have removed we have removed 56 liters from the first part, 42 liters from the second part and 154 liters from the third part. And also we have removed the equal number of buckets. So capacity of bucket is basically common factor of 56, 42 and 154. So common factor, that is highest common factor of 56, 42 and 154 is 14. HCF is 14. Hence I can say that the capacity of bucket is 14 liters. So out of 65 liters, if I have removed 56 liters, then to remove those 56 liters, how many buckets will I need of 14 liters? So 56 divided by 14, that will give us 4 buckets for the first part. 42 divided by 14, that is 3 buckets for the second part. 154 divided by 14, that is 11 buckets for the third part. A total of 18 buckets are removed. So 4 plus 3 plus 11, it's 18. So option 3 is the final answer. Thank you.